Hello everyone, I'm Navya and I'm an assistant professor from CSIT department, MLR Institute of Technology. So welcome to the session Object Oriented Programming through Java. Today we are going to discuss Java Virtual Machine. Before going to this, let us see, in the last class we have discussed about features of Java. Then in today's class we are going to discuss the most important topic of Java is architecture of Java Virtual Machine. So what is Java Virtual Machine? So I already discussed Java. Some languages will use the interpretation, some languages will use the compilation. But here Java uses both techniques, the compilation and interpretation. Java code is first compiled, that would be converted into bytecode to generate a class file. Okay, so this class file is interpreted and it will change the .class file to the machine, Java Virtual, interpreted by the Java Virtual Machine for the underlying platform, which means the sample, the .class file can be executed on any version of virtual machine of any platform or any operating systems, which we have discussed the topic called in the Java buzzwords. We have seen architectural neutral. So this is where we use architectural neutral as a Java buzzwords which we have using in Java Virtual Machine. Okay. So similar to virtual machines, Java Virtual Machine creates an isolated space as a host machine. Here this space can be used to execute Java programs irrespective of platform, operating system of the machine, which is nothing but whenever you generate the .class file. Okay, whenever you generate the .class file, once the compilation is completed, that could be executed on any platform and on any operating systems which consists of JVM. Okay, so what JVM consists of? Basically, JVM consists of three distinct components. One is class loader, the second one is runtime memory or data area, and execution engine. These are the three important methods, important components which were existing in Java Virtual Machine. So let us see the Java Virtual Machine architecture. So here is the architecture. So what class loader consists of? Loading, linking and initialization. So these are the three phases under class loaders. And runtime data area. In runtime data area, you will have method area, heap area, stack, program counter register and native method stack. So these are the runtime data area where the storage, we can simply say the storage. Next, execution engine. In the execution engine, you will have the interpreter, just-in-time compiler and a garbage collector. Okay, so these are the three phases you have to undergo in execution engine. Then you will have another component called Java native method interface. We will call it as JNI, and related to this Java method interface, the supporting methods has been included in Java method library. So we are taking Java, these are the other two components you have other than these three. Okay, let us see the one by one component here. Okay, coming to the class loader. What this means a class loader? So when you compile a .java source file, so here what it will do, it will convert the bytecode as a .class file, isn't it? So where this class loader, before converting this to this, so the class loader first loads a class into the main memory. Now the first class loaded in the memory is the class which consists of the main method, whereas a class which has main method as a member method, so that class has to be loaded into the memory. So which class it will be loaded? So the class which contains the main method, the class will be loaded into the memory first. Next, there are again three phases in the class loading phases. We already said that, right? Loading, linking and initialization. And coming to here, so in loading phase, again you will have three types of loaders. One is bootstrap loader, one is extension class loader and one is application class loader. Whereas in the linking, again you will have the three phases: verifying, prepare and resolution or resolve. And whereas initialization, you will have another phase called initialize. Here, coming to the loading phase, we have discussed there are three loaders we are having, right? So loading involves the binary representation, nothing but the byte class of a class or interface with particular name and generating the original class or interface from that. Okay, so what it will do is it will loads into the main memory the classes. So there are three built-in class loaders which are already available in Java. The first one is bootstrap loader. So what type of classes it will load is, this is a root class loader. We will call it as root class loader. It is a super class of extension class loader, which is the first class loader is bootstrap class loader. Okay, so it will load the standard Java packages like java.lang, .net, .util package, .java IO and .swing packages and so on. So these all will come under bootstrap class loader. Here the packages where it is located is whenever you install the Java programming language, it is installed in library directory. Okay, so the next class loader is extension class loader. So first is a bootstrap class loader. So this is parent class. It's in parent class. Okay, and extension class loader is a child class of bootstrap class loader. Okay, so here in this it's in subclass or the child class of bootstrap class loader. What it will do? It will have the application class loader. It loads extensions of a standard Java libraries. If you are having any extensions with that, so that would be loaded in this class loader. Okay, so these extension library will happen. So here, see here, it was in jre.lib function, lib directory. Here you will have in this library, again you will have ext folder. So there you will have this. Okay, and next, application class loader. Application class loader is a subclass or child class of this class. Okay, so you can say this as super parent class, and this is parent class, and this is child class. Okay, application class loader is a child class of extension class loader. Extension class loader is a child class of bootstrap class loader. Okay, so where it is located? So here the files present on the class path. So whenever you are having the class path as in files, for the files that would be loaded in application class loader. The applications, applets, everything will happen in application class loader. So here how you are going to, here you have to set class path in order to use the application class loader. So in order to set the class path, you have to set the current directory of the application using you can go with the environment variables in the system library, or you can have the options can be -class path or -cp in the command line arguments. So this is all about loading. So there are three types of loaders. One is bootstrap class loader, extension class loader, as well as application class loaders. For the standard Java packages, we will use the bootstrap class loader. For the extended Java libraries, we will use the extension class loaders. For the application purpose, which are under class path, we'll use the application class loader. Okay, coming to the linking section. So in linking section, after what the loader will do, it will load the classes which you have written in the Java code file, that would be loaded into the main memory. Now it undergoes with linking section. So linking a class or interface involving combining different elements and dependents of the programming together. Okay, so linking includes these steps. What are the steps? First is verification. First it will check whether the particular class, whatever you have written, that would be structurally correct or not. So it will check the structural correctness of a dot classify by checking a set of constraints or rules. So which we have the rules like if you are missing some semicolon, or if you are missing some or close brackets, parenthesis, or anything, or if you miss some double quotations, everything will be checked here. So if the verification fails, you will get the exception called verify exception. Okay. Next, after everything is correct, then it will go to the preparation. Here JVM allocates memory for the static fields like class or interface and initialize dims with the default values. Okay, here it allocates the memory for the static fields like class or interface. If any static classes are there or static interfaces are there, so it will allocate memory for that and it will initialize the default values. Next, resolution. So it will, in this phase, we will use symbolic references are replaced with direct references in a runtime constant pool. In the runtime constant pool, whatever the references you are given, that would be replaced with the direct references. Okay. So next phase is initialization phase. So initialization. So here initialization, executing the initializing include method of class or interface. So whatever you are giving the method, whenever you are creating an object to an interface or class, that would be using class constructors. It will assign the basic values, default values to it, or it will allocate memory using this phase. So classes, constructors, executing the static block and assigning values to all the static variables. So this is the final stage of class loading. Okay. So for example, if you are declaring some static variable like enabled equals to true. Okay, so by default it will take as false. Okay, so the variable enabled was set into default value false during the preparation phase. Okay, here in the initialization phase, the variable is assigned actual value of true. So here the JVM is multi-threaded here. Whenever it happens, the multi-threads are trying to initialize the same class at a time, it leads to concurrency issues. So whenever multiple threads are going to initialize the same value, it will lead to concurrency issues, and you need to handle thread safety to ensure that program works properly in multi-threaded environment. Next, runtime data area. So there are 5 components in this. What are those? Method area, heap area, and stack area, program counter register, and native method stack. These are the 5 components which are present in runtime data area. First phase is loader, class loader. Second phase is runtime data area. Okay. So coming to the method area. So what are the methods? In the runtime constant pool, fields or method data, the code of methods and the constructors, everything is stored in. Here in the runtime method area, we use this area, the runtime method area, completely for the storage. Okay, so what type of storage it will be stored? Okay, here the runtime, here it will store the runtime constant pool, fields as well as method data and code of the methods and constructors. So if you are asking for a method area and it is not sufficient of the program startup, so still you need the extended memory, then JVM throws an error called out of memory error. If you are asking for the large amount of memory, then available amount of memory. So here the method area is created on virtual machine startup. This is only one method area for JVM. Okay, coming to the stack area. So stack area is created whenever a new thread is created, whenever a new small process is created, a separate runtime stack is also created at the same time. So this all local variables, method calls and partial results are stored in the stack area. In this, what the threads requires large size than what's available, which we have seen before. If whenever you are JVM to started in the method area also, here also, if the larger stack size, if you require the larger stack size than what's available in JVM, so it will throws an error called stack overflow error. For every method call, one entry is made and stack memory, which is called a stack frame. Whenever you are calling a method, so that would be saved in some memory, some separate memory. That particular memory is known as stack frame. So when the method call is completed, whenever you are calling, for example, in the main method, I am calling some function. So this function will be stored in the stack area. So this is called as stack frame. Okay. So whenever I call this function, as it gone to the function method and it executed all the statements and the control come back to the main function, this function it goes to the next step, then this would be destroyed. Okay. So again the stack frame is divided into 3 subparts. The first one is local variables. So here this stack frame, every frame contains an array of variables known as local variables. Here whatever the local variables and their values you are giving inside the method, so those are stored in the local variables, and the length of the array would be depended by the compile time. Okay. And operational stack. What is operation? If you are going with an operand, it is also known as operand stack. So it's a lost in first out stack wherever. So for example, if you are converting from infix to postfix or postfix to prefix, such operations if you are doing, okay, so those things will be saved in operand stack here. Here, in order to have this loss, whatever you have, for example, if x plus y, x will be stored plus and y like this. So lost in first out would be happen. So the operations you are doing, that would be saved in operand stack. And frame data. Frame data is nothing but all symbols corresponding to the method are stored here. And this stores catch block information in case of exceptions also. So we did not discuss about the exceptions, right? So the catch block information of the exceptions will store here. And next one is program counter register, native method stacks. So program counter register. What is program counter register? Multiple threads. If Java supports multiple threads at the same time, so multiple threads executing at the same time is known as multi-threading concept. Here, when multiple threads are executing at the same time, the thread has own program counter register. Each thread will be stored in one program counter register. Okay, so the first thread, if I'm having n number of threads, this is thread 1, thread 2, thread 3, thread 1, thread 2, thread 3. The address of thread 1 will be saved in one PC register with some address, and second thread will be stored another PC register, and third one will be stored in another PC registers. So each instructions, whenever you are executing each instruction, the PC register will be updated with the next instruction respected through the threads. Coming to the native method stacks. Native method stacks are nothing but if Java will support for the other languages also. So the methods which you have written in other languages like C, C++ or Python or anything that supports in JVM. Okay. So if you are undergone with such type of threads, that would be saved in the native method stacks. So for every new thread, a separate native method thread stack is allocated. Next, the third phase is execution engine, consists in the execution engine. So the next phase is here. You have done the loading phase as well as the stack area, runtime area you have completed, right? So now it's an execution engine. Here we will change the bytecode is loaded into the main memory and details are available in the runtime data area. So whatever the bytecode has been loaded into the main memory and the details are available in the runtime data area. So here this is the next step to run the program. So the execution engine handles this executing the code present in the each class. So here the bytecode needs to be converted into machine level language. So we are compiling it, it links, loads, as well as the dot class file will be generated, and then while executing. So the bytecode needs to be converted into the machine level language instructions. So what is this? So here in order to first you will compile. First you will have a source code. Okay. Source code will, when you compile the source code, you will generate the dot class file of particular source code, and then you will interpret it. Then that would be changed to machine language. Okay, so here in order to change the dot class file to the machine code, here we will use the interpreter or JIT compiler for the execution engine. Okay, so in the execution engine again you will have the three called interpreter, JIT compiler and garbage collector. Just-in-time compiler, interpreter, just-in-time compiler, as well as garbage collector. So what is interpreter here? Interpreter, some languages will use the interpreter. What happens in the interpreter? Interpreter is a program, or you can say it's as a software that would execute whatever the source code you are taking, that would take, and it will reads and executes line by line, and it will convert the particular source level language to the machine level language. That is the property of interpreter. That is the process of interpreter, which will do same as a compiler. Then what is the difference between interpreter and a compiler? Interpreter will reads and executes the bytecode line by line, whereas the compiler will take a block at a time. Okay, so here the interpreter reads the bytecode instructions line by line. So what happens due to line by line execution? It would be comparatively slower than the compiler. Okay, so this is the main disadvantages. So when a method is called multiple times, every time the interpretation will be required. So every time it will check line by line. So this is the main disadvantage. Then what is JIT compiler? Compiler overcomes, so whatever the disadvantages we occurred in the interpreter will be overcome by the JIT, just-in-time compiler. So here what it will do, first it will use the interpreter to execute the bytecode, but when it finds some repeated code, it uses the JIT compiler. So whenever it was repeated code is occurred, then it will uses the JIT compiler. So what JIT compiler will do, it compiles the entire bytecode and changes it to the native machine code. Okay, so whatever the repeated method is there, whenever repeated method calls, it improves the performance of the system. Again, it does not check the line by line. Again, it will hand over the control to the JIT compiler. The compiler will compiles the bytecode, and whatever it's already reads and executed, right? So whenever I'm calling the same method, it will go with the method calls and it will improve the performance of that particular system. So in JIT compiler, you will have again the following components. So what are those? Interpreter code generator, which generates the intermediate code, and code optimizer, or it's optimizes. If I'm having like this x int x equals to 0, for example, so it would be optimized to int x equals to 0. The two lines will be converted into one. So optimizing is nothing but reducing the code into a effective one. Okay, that is code for the better performance. This will be used for the better performance. Now target code generator. So it will convert the intermediate code to the native machine level machine code. So these are the three components which you are using in the JIT compiler. And profiler. Profiler finds the hotspot, the code that executed repeatedly. Which code is executed repeatedly, that would be found by the profiler. So these are the two components in execution engine, and the third component is garbage collector. So what is garbage collector? Garbage collector is nothing but whatever the unnecessary or unreferenced objects are there, that would be from the heap area, it will delete it, it will remove it. So garbage compiler collects and removes unreferenced objects from the heap area. Okay, so you can say it's a process of reclaiming the runtime unused memory automatically by destroying them. So we have seen the feature called robustness, isn't it? How you become the robust means whatever the things you have installed, or whatever the objects you are created, what are the methods you are created, what are the data variables you are created. So after the usage of those things, we will directly derefer them or unrefer them, or will remove all those things using garbage collector. A strong garbage collector has been given here. So garbage collection makes Java memory efficient, which I said you now. So it will derefer the objects from heap memory and makes free space for new objects. So again it has two phases. One is mark and one is wipe. Okay. Mark in this step, what the garbage collector, it identifies the unused objects. Okay, first it will identify the unused objects in the memory. In sweep, the garbage collector will remove the objects identified during the mark phase. Okay, so this is execution engine. So the garbage collection is done automatically by the JVM at regular intervals and does not need to be handled separately. After allocating memory for a particular object, you need not to deallocate it. So it automatically deallocated by using the garbage collector here. So it can also be triggered by calling system.gc. So using this method also you can, but the execution is not guaranteed, but using this function also you can go with the garbage collector. Next, garbage native interface. So here I already said you before, the native languages. So the other than Java, non-Java code. So if this can be in cases where we need to interact with the hardware or to overcome the memory management and performance constraints in Java, this supports the execution of native code via Java native interface. So the other languages, JNI will act as a bridge between the supporting packages to other programming such as C, C++ and so on. Here whatever the programs you have written in other languages can be interacted with JVM using Java native interface. So you can use a native keyword to indicate the method implementation which is provided by the native library. Okay, so here you will have the method system.load library, which is used in order to implement those classes or to get the bridge between the native interface. So here we will use this method. Next, Java native libraries. So these are the libraries are written in other programming languages. So these are the libraries which are written in other programming languages such as C, C++ and assembly. So these libraries are usually, it will support the JNI Java native method interfaces. So that present in .dll and .so files, and these libraries are loaded through Java native interface. This is all about architecture of Java virtual machine. So what we have discussed in today's classes, what architecture consists of 3 phases. One is class loader, and the second one is runtime data area, and the next one is execution engine and JNI Java native interface and Java native interface libraries. So we are having all these 5 components in Java virtual machine. So again, class loader is of 3 types. One is bootstrap class loader, extension class loader and application class loader. Okay, what happens in the class loader is, again it happens 3. What is this? Loading, linking and initialization will be done in class loader. What are the things, what are the components you are having in the runtime area? Again, you will have 5. What are those? Method area, heap area, stack area. Okay. PC register, and the last one is native method stack. Okay, so these we have learned. And in the execution engine, again you will have 3 phases. One is interpreter, just-in-time compiler, and the last one is garbage collector. And again, Java native interface applications as well as Java native interface libraries which support JNI. So this is what we have learned today. Thank you for the session.